Welcome to Monthly Math Moment, the web series where we take a quick peek into the modern elementary math classroom. I'm your host, Amanda McIntyre. One of the big changes that families may notice about their child's education is how they learn multiplication facts. You may have strong memories of doing time tests or writing out times tables, or if you were lucky, maybe playing a big game of Around the World to memorize your facts. Although games are still a big part of learning our multiplication facts, and automaticity is still the ultimate goal, modern math teachers have moved away from the traditional techniques of just memorizing towards teaching students strategies that build on how they learn naturally. With time and repeated practice of these strategies, the students eventually become automatic in all of their times tables, while also building a conceptual understanding of multiplication. Much like addition, learning your multiplication facts starts out with strategies that build on what students already know about counting. Let's take a look. We are going to solve 5 times 3 today. Can you write for me 5 times 3 as an addition number sentence? Oh my goodness, beautiful. So you have 5 plus 5 plus 5. How can we find that answer?
We can start by adding 5 plus 5 by doing 5 times 2.
Okay, so what is that?
That is 10.
10, and then we add 5 more, what do we get?
15.
15, so we could go 5, 10, 15. Beautiful, since you found the answer, would you like to write it in?
Yes.
Beautiful, and 5 plus 5 plus 5 is 15, so what's 5 times 3?
15.
Go ahead, write it right in. Nice work! As students become solid in their repeated addition and skip counting, they will start to memorize a core set of facts, typically starting with their 1s, 2s, 5s, and 10s. With this core set of facts, students can then use the properties of multiplication to help them figure out other facts that they don't know. Let's see how students use the commutative and distributive properties of multiplication to solve for facts they don't know. 7 times 3. What is 7 times 3? How could we figure that out?
You can draw 3 groups, and then you can put one. Then you can put 7 in each one.
Why don't you do that? All right, now that you have 3 groups of 7, how are you going to figure out what 7 times 3 is?
I can count them all together.
Go ahead, count them all up. I think you might have counted one twice.
Yeah, I know.
So it should be 21.
21.
You got it. So you have this beautiful drawing. 3 groups of 7, you got 21.
I just
all right, ready?
At first.
I'm wondering, don't erase it. I'm wondering if you can use this problem to help you figure out 3 times 7.
Let's just switch. It's also 21.
What? It's just turned around, so it's 21?
Mm-hmm.
Great work, Cody. I have a math problem here. I want to solve 7 times 6. And I already know if I have 5 groups of 7, I'd have 35. How could I figure out what 6 groups of 7 would be?
Okay, you could draw 6 groups.
Well, I already have 5 groups. Do I need to draw 6 whole groups?
One more.
One more group. Go ahead and add one more group on there. 1, 2, 3, 4, 5, 6, 7. Beautiful. So if I had 35 black dots and I added 7 more, how many would that be?
42.
So what's 7 times 6?
40. 42.
Nice job! How about I want to solve the problem 7 times 4. And I don't know that one in a snap. But I know that 7 times 5 is 35. Can I use that to help me figure out 7 times 4?
Yes, I think that can help you because it's only one away.
All right, show me what you would do.
Alright, so if we have 35, and then I know that 1, 7 equals 7, so then minus 7 equal there. So then the answer would be 28.
Can you put the answer in for me?
Alright.
Beautiful. So you started with 35. You took away one group of 7 and you got 28.
Yep.
Nice job. I want to solve 4 times 3. But I only know the answer to 2 times 3. Do you know the answer to 2 times 3?
It's 6.
It's 6. So how can I use 2 times 3 to help me figure out the answer to 4 times 3? What could I do?
It's just basically 2.
Excellent. So you took that 4 and you split it up into 2 plus 2. So you could do 2 times 3 plus 2 times 3 and get 12. Well done! I want to solve 6 times 7. And I'm thinking in my head, I don't really remember that one, but I do remember that 6 times 5 is 30. And I remember that 6 times 2 is 12. Do you know how I could use these 2 facts to help me figure out that one?
You could 30 plus 12, and that would create 6 times 7, because 6 times 2 equals 12, and 6 times 5 equals 30. So if you put those together, it would equal this.
Oh, because I have 5 and 2, that equals the 7. Okay, so what is it if I put 30 and 12 together? What do I get?
You get 42.
So then 6 times 7 equals, can you answer that for me?
42.
Beautiful. So I see you used a vertical adding method to find that 42, and that's how you found the answer? As I mentioned at the beginning, we don't expect students to use these strategies forever, but with lots of time and practice, eventually they will memorize their facts. As families that wish to support their students, I recommend practicing with lots of games. I will link to our episode about games at the end of this video. If you're interested in learning more about the learning progression and what students go through to learn to multiply and divide, be sure to check out the links in the description below. Next time on Monthly Math Moment, we'll be digging into the difficult learning progression of learning how fractions are a number. Until then, thank you for tuning in to this month's Math Moment.